Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see about some of the commonly asked interview questions. We are going to cover what is the expectation from the interviewer, like what is the reasoning behind asking those questions. Also, I'm going to cover about the concepts of those interview questions so that you better understand what those concepts are and you will be able to better respond in your interview when these questions are asked to you. So let's get into the topic, and then the first question that we are going to go through today is how to handle an unbalanced data set for a classification problem. So if someone is asking you in an interview, like how do you handle an unbalanced data set for a classification problem? So the reasoning behind it is they want to understand whether, first one, like whether you have experienced any of these scenarios or not. So even if you have not experienced, do you have the knowledge to understand like what is an unbalanced dataset? What are all the various issues with unbalanced dataset? And do you know some of the options that are available in order to solve the problem when you have an unbalanced dataset? So that is the reasoning. So first, what they want to know is they want to understand whether you know about the concept. So what is an unbalanced dataset? So let's say a dataset where there is a fraudulent transaction. So for example, let's say banking transactions and then there are few fraudulent transactions. So this particular problem will be highly unbalanced. The reason because every minute thousands of transactions will happen, but there are very few fraudulent transactions. But it is extremely important for us to identify those fraudulent transactions. So let's take an example. Let's say there are about 10,000 transactions that are taking place and there are 100 transactions which are fraudulent. So which is approximately 1%. The problem with an unbalanced dataset is we can't directly use something like a confusion matrix like precision and recall. Why? Because out of 10,000 transactions, there is only 100 which is fraudulent. So let's say I'm going to build a model which predicts that every transaction is a genuine transaction. So every transaction out of all the 10,000 transactions, like whatever it might be, so every single transaction is a genuine transaction. So what will happen if you are going to use the confusion matrix? It will tell you that your model is 99% accurate. But what is the actual case? You are not making any prediction. You are saying that every single transaction is genuine. That's it. You are not building any model. And still, you are getting an accuracy of 99% because the dataset is unbalanced and there is only 1% which is fraudulent. And we are not making any prediction of those fraudulent dataset. So it is very important for us to understand like the issues with an unbalanced dataset so that we can address it. Okay, so now how can we address it? So now the interviewer will be expecting you like to respond like how can you handle it. So when you have an unbalanced data set, basically there are like two commonly used approaches in order to solve it. So one is called as undersampling. The second one is oversampling. So coming to the first one, undersampling. So what we do here is, let's say we have the training data set like 10,000 transactions, out of which only 100 is fraudulent transactions. So what we do is we take all the 100 fraudulent transactions, or let's say we take a 90 of those fraudulent transactions. And then what we do is out of the genuine transaction, like there are 9,900 genuine transactions. So out of it, let's say we take only 10% of it. So let's say we take only 900 of those transactions. So we combine these two in order to create a new training data set. So here the contribution of fraudulent transaction is much higher because what we are doing is we are undersampling like the case where like the majority of the class, like for example the majority of class here is genuine transaction. So we are undersampling on the data set of the majority class. So by doing so, what we are able to do is we are able to create a new data set which is slightly better, like which is not unbalanced, like which is no longer unbalanced. So we can use it in order to build the model and we will be able to use the same confusion matrix in order to solve the problem. But here when we are doing undersampling, there is an issue that might come up. So maybe the interviewer would expect you to maybe proactively come up with like those issues and how you will be able to handle those issues. The issue here is loss of information. The reason why it could happen is out of the 9,900 transactions, which is genuine, what we are doing is we are only taking 10% of it. So there is about 90% of data which we are ignoring, which might have a lot of useful information. So what we are doing is we are just taking a subset of it and hence there could be a loss of information. So how do we handle it? We can handle it by using an embedding approach, by creating an ensemble model. So instead of just selecting just 10% of this data as a subset, what we can do is we can randomly select various 10%, like some random 10% of data multiple times and create model multiple times. And then what we can do is we can take the average of those in order to make the final prediction. So by this way, what we are ensuring is we are ensuring that there is no loss of information. So now coming to the second method, which is oversampling. So what is oversampling? So as the name suggests, what we do here is, so here we don't do any modification or we don't do anything with the majority class, which is like genuine transaction. But what we do is we take the minority class. So out of 10,000 transaction, like 1%, 100 transaction are fraudulent transaction. So we take those fraudulent transaction. What we do is we duplicate it. So what we do is we make 100 fraudulent transaction into 1000 fraudulent transaction. So we duplicate each record like 10 times. By doing so, what would happen is we would have a data set which is much more balanced. So we will have a data set which has 10% of fraudulent transaction. But what we are doing actually, we are actually duplicating the transaction that we already have. So in this approach, again, there is an issue. So here, what is the issue? The issue is there is a chance for overfitting, because what we are trying to do, we are trying to take a small number of fraudulent transactions and we are duplicating it. And hence, when we are going to use like the same data so many times, what the model will happen, like what will happen is the model will try to overfit, like maybe it will be overfitting. So how do we solve this problem? So we can solve this problem by using cross-validation. So if you are going to use oversampling method, what you need to ensure is you need to ensure that you use cross-validation to validate whether the model is overfitting or not, whether there is any bias in the model that you have built. So that is it about handling the unbalanced dataset for classification problem. So as I explained, what you can do is you can start with an example, like example for an unbalanced dataset. And then you can explain about the various issues, like why you can't use confusion matrix. And then you can come to the various methodology that can be applied in order to solve the unbalanced dataset. So which is nothing but undersampling and oversampling. So each of these methods has their own issues. So how do we address those issues? Like what kind of techniques we can use to address those issues? So if you are able to explain all this, so then that will be a perfect answer for this particular question. So next time in an interview, if someone is asking you how to handle an unbalanced dataset for a classification problem, so you should remember all these concepts. So then it will ensure that you are able to create an impact in the interview. So now coming to the second question. So the second question that commonly asked in many data science interview is, what is the difference between cross-validation and batting? So both these approaches are completely different. Their objectives are completely different. Even though like their methodology, the approach which we follow are quite similar, but their objectives are completely different. When you are asked this particular question in your interview, so what the interviewer is expecting is, the interviewer is expecting you to know what cross-validation, what batting is, and the interviewer would expect whether you know what is the objective behind using an cross-validation technique. So in what type of scenarios you use cross-validation, and in what kind of scenarios you will use an batting approach. And they will also expect you to know the methods that is involved in implementing both cross-validation as well as batting. So coming to the first one, what is a cross-validation technique? So a cross-validation technique is used in order to evaluate the model, evaluate the predictive model that you are building. So what you are trying to evaluate, if there is any bias in the model that you have built, if there is any overfitting that is happening in the model that you have built. So why do you need to know about all these things? If there are any records that are duplicated, as we saw in the previous question, let's say your dataset is unbalanced dataset. So in order to address the issue of unbalanced dataset, maybe you are duplicating some of the records. So whether that is contributing to an bias or overfit in your model, or simply your dataset without any modification can contribute to an overfitting. So this particular technique will ensure that the model that you are trying to build is not biased and is not overfitting. On the other hand, when we take the batting approach, what we are trying to do is we are trying to take the average of those models to reduce the variance the prediction is subject to. So the objective is very different. As you see, we are using the batting approach in order to improve the accuracy of the model, in order to improve the performance of the model. Whereas when we say cross-validation, what we are trying to do is we are trying to evaluate the performance. Cross-validation will not help you to improve the accuracy of the model. It will just say you how good your model is, how unbiased your model is. Whereas Bayesian approach helps you to improve the accuracy of the model. We are trying to take the average of multiple models and we are trying to ensure that the outcome that is produced by the model is much more accurate. Okay, so now what is the methodology? What is the steps behind the cross-validation? So in a cross-validation technique, what we usually do is we divide the group into we divide the dataset into trade groups. So we usually call it as k-fold cross-validation. So let's say we have a dataset, we divide it into 5 different groups. So then what we do is we set aside the first group. Let's say we have 5 groups. We set aside the first group. We train the data on the remaining 4 groups of data. So once we have trained the data, what we do is we predict on the test dataset, which is the first group that has been pushed, that has been taken aside. The same step is repeated for each of those 5 groups. So then what we have is we have 5 different models now. So now what we do is we take the mean as in the variance of those models, like the accuracy score of those 5 models, and we check if there is any bias in the dataset. If there is any model that is much different from the other one, to see how good the model is, right? Ideally, if all those 5 outputs are close to each other, so it means that your model is quite good. Your model is performing quite good in a variety of dataset. So that's what would happen in the cross-validation technique. On the other hand, so if I am going to take the Bayesian approach, what would happen is, so it's something very similar. So what would happen is we divide the data, we take some random sample, we build the model on the random sample, and similarly what we try to do is we try to take multiple random samples. Like we can take multiple random records, as well as we can choose random features as well. And we try to build multiple models, and then we take the average of all those models in order to make the final prediction. So by this way, what we are trying to do is we are trying to ensure that there is no bias in the model that we have built. There is no overfit that could happen in the model. So when we generally use an ensemble technique, like for example, random forest is a classic example of Bayesian approach, where we try to build multiple trees. When we take the average of all those, the accuracy of those ensemble model will always be better than any single model that has been used in order to build the forecasting or in order to build the predictive model. So that is the difference between cross-validation and Bayesian approach. So cross-validation, always remember that it is to evaluate the performance of the model, whereas Bayesian approach is to use in order to improve the performance of the model. So that is the basic difference between these two. Coming to the third question, what is the difference between an histogram as well as box plot? So when an interviewer asks you this particular question, like the reasoning behind it is that the interviewer is checking whether you know what is the difference between histogram and box plot. What is the advantage? Like in what type of scenarios you use an histogram and in what type of scenarios you use an box plot. So first one is histogram helps you to come up with a frequency distribution of the value. So it helps you to understand the shape of the distribution. So when you have a shape of a distribution, it helps you to see whether there is any skewness or bias in the data set. On the other hand, if I take a box plot, so the box plot will help you to get an information such as what are all the various quartiles, like 25th quartile, 50th, 75th and 100th quartile. What is the range and if there are any outliers in the data set. So and box plot helps you to get an information about various ranges of values, like what are all the outliers, like what is the 75th percentile, what is the range where like a majority of the data set like data falls into. And the box plot, like it occupies very less space in the memory, so it is much more efficient. Like you can come up with multiple box plots with very few resources. Another advantage or another reason why you use box plot is to make comparison about all those attributes. Let's say you have multiple features. You take all those numerical features and then by using the box plot, you will be able to understand what is the range of those values. So let's say you use some kind of a distance-based algorithm. So maybe something like an SVM. So where it is important to understand what are all the various features, what is the scale of the features when you what is the scale of the features, especially if you are using a distance-based algorithm. Because if there is a particular feature which is of higher scale and there is another feature which is of very, very low scale, so then it impacts if you are using distance-based algorithm. So what you need to do is you need to come up with a transformation which transforms all the features into a consistent scale. So that is the difference between histogram and box plot. So histogram helps you to understand the distribution. It directly says whether there is any bias or whether there is any skewness. And on the other hand, the box plot will also help you to understand whether there is skewness, but the primary objective is to get information like what are all the various quartiles, and to do the comparison between the different features to see whether they are in same scale or not. So that is the difference between an histogram as well as an box plot and the different scenarios where they can be used. That is it for today. I hope you have learned or you have understood some of the concepts behind the most commonly asked interview questions. And if you know someone who is trying to learn data science or trying to get a job in data science, please share it with them so they can be aware of some of the commonly asked interview questions, and then they could understand what are all the concepts behind those questions, what is the reasoning behind like interviewer asking those questions, what is the expectation, so they can be well prepared for the interview that they are going for. So that is it for now. See you in the next session. Bye until then.